Okay, let's start with the second half of this review. I may have already started this. Whoops. This one says perform the indicated operation to simplify each expression. Write the answer in standard form. So again, if you look at where I drew this initial arrow, we always look between, right, these polynomials to see if we're adding or subtracting or multiplying. This looks like it's addition. So we find the like terms. We've got a negative 7r cubed, and we've got an r cubed, which gives us this negative 6r cubed. 4r minus 5r would be negative 1r, or negative r. And we've got r squared plus 4r squared, right, would be 5r squared. Now in standard form, right, I would reorder those. And we talked about when you combine like terms, if you choose them in highest to lowest degree, then they'll already be in standard form. So this one's multiple choice. Looks like A is our answer there. Number 15, again, we look between them. Notice there's no addition or subtraction. This one is multiplication. So this one we are going to start to distribute or FOIL. If you like the box method, you can draw your box. So 7n times 2n is 14n squared. 7n minus 8 is negative 56n. Then we continue with the negative 1 times 2n is negative 2n. And negative 1 times negative 8 is a positive 8. So that gives us 14n squared. When we combine negative 56 with negative 2, it gets more negative, leaving negative 58n plus 8. So it looks like this answer is also A. Number 16, same idea. It's just not multiple choice. So again, you can build your box if you'd like to, or distribute. Maybe I'll draw a box on one of these. So those of you that like the box method, right, we put one of the polynomials on the left with each term having its own row and one across the top. And then we multiply to fill it in. So 4m times m is 4m squared. 4m times 1 is just 4m. Negative 2 times m is negative 2m, and negative 2 times 1 is negative 2. Now looking at that, we can combine those middle ones. So we've got 4m squared out front. We've got 4m minus 2m, which is positive 2m, and then minus 2. 17, remember when we see this squared, if a polynomial is squared, that means there is two of them, or are two of them. So we can't just put that squared on each piece, we'll be missing terms. So we said we practiced writing these side by side to help us remember that we're going to, again, use that box method or go ahead and distribute here. So 5 times 5 is 25. 5 times 8v is a positive 40v. And we continue. 8v times 5 is positive 40v, and 8v times 8v, 64v squared. Again, it asks us to write it in standard form, so as I combine these middle like terms, I'm going to put the 64v squared first, combine those middle ones to get 80v, and then I'll put that 25 that's constant at the end there. Jumping down, factor each of the following expressions completely. So we are into factoring. Remember, we follow those few steps. So number 1, we make sure that it's in standard form. These ones are all given to you in standard form, so why do I write that step? The biggest thing is we will do many in the future when they're not, and so we want to make sure that they're in standard form so we connect the right pieces. Then step 2, right, we always look for a greatest common factor, and if there is one, we divide it out and put it out front. Step number 4, or skipped 3 there, we factor that middle part if we can, right? And that's as far as we can go because there's nothing to solve here. So again, on 18, notice it's already in standard form. Looks like there's not a greatest common factor that divides out a 6x squared, negative 5x, and a positive 1. So this one does have a number out front, right? This one we need to use that bottoms up method. So we multiply the 6 to the back. We get x squared minus 5x plus 6. And then we go ahead and we factor this piece right here. So we split up the x and x. Factors of 6, right? It's a positive 6, so they need to add or combine to that negative 5. So it looks like they'll both be negative. We've got 6 and 1, but those add to 7. So we're going to go with 2 and 3. 2 times 3 we put here. And then remember, you got to finish bottoms up. You're not done. And I always just check my answer at the end, whether I did bottoms up or not. So if I do x times x, notice I don't get 6x squared. When you do first times first, you have to get the first piece. So always check your answer. that way, and then that will remind you that, oh, I'm not done with bottoms up because I needed to divide that 6 back out. And when I do that, one of the things I noticed on the homework, make sure you simplify these fractions. So 2/6 is 1/3. Before you can pull things up and the bottoms up, you've got to simplify the fraction. Otherwise it leaves other greatest common factors still in there that weren't even there in the first place. So make sure we do that. And then go ahead again, move that bottoms up. So 3x minus 1 would be one of the factors. Move that bottom up. And 2x minus 1 is that second factor. Okay. Number 19, again going through the steps, it's in standard form. There is not a greatest common factor, it looks like, that would divide out of all of them. So we go ahead and split it up. That b squared is already by itself, so we know that it will just be b and b. Now this one we're looking for factors of negative 20, so they need to be different signs to give us a negative, and it looks like they need to have a difference of a negative 1, so it's like a negative 1b. So 20 and 1, those have a difference of 19, not going to work. 2 and 10 have a difference of 8, those subtract to 8. 4 and 5, those have a difference of 1. And if I want it to be a negative 1, I do 4 minus 5. So we're going to have a negative 5 in here somewhere and a positive 4. And again, I can check my answer. B times b, excellent, b squared. I get a 4 minus 5 is that negative 1, and then negative 5 times 4. All right. Oh, we better do another joke before we keep going. I hope I remember which one I did in the last video. So here's the next one. How do you make 7 even? You just have to take away the s. I'm going to write it out for you so you can see it. See if we take away the s. Even. All right. Moving on. Number 20. X squared plus 11x plus 10. So again, the x is already by itself. There's no greatest common factor, so we just split up the x. We're looking for factors of 10 that add, because it's positive, to 11. Everything looks positive in this one. So it looks like 10 and 1 would work great. So 10 and 1 adds to 11. We're done. Number 21, again, we look for a greatest common factor. It looks like all of these are divisible by 2. So we're going to divide out a 2. Now when we do that, again, the 2 doesn't disappear. It stays out front. So we divide that, we end up with x squared. Negative 4x divided by 2 is minus 2x, and negative 160 divided by 2 is negative 80. So we did that step 2, right? We took out the greatest common factor. Now step 3 is to keep factoring that piece if we can. So inside here we've got 2. We split up the x and x. We need factors of negative 80, so different signs, and it looks like they need a difference of that negative 2 in the middle there. So let's do 10 and 8. If we do negative 10 and a positive 8, that has a negative 2. Excellent. All right, number 22. Again, we look for a greatest common factor. There's not one here. So we notice that 3 is stuck out front. So we go ahead and multiply it to the back. We get n squared minus 19n minus 120. In this one, right, we're looking for factors that multiply to negative 120, and they need to have a difference, because it's a negative, of 19. So this one might take a little bit longer, right? We know that it ends in a 10, so 10 and 12, those have a difference of 2. 4 and 30, those have a difference of 26. 6 and 20, so have a difference of 14. We're getting closer. 5 and 24. Yeah, those would subtract to 19, and then the 24 negative, so that it's a negative 19. So we know this is going to be n plus 5 and n minus 24. Now again, notice if I start to check my answer, n times n does not give me 3n squared. That means I needn't finish the bottoms up method. So I'm going to finish it by dividing out that 3 that we put in. And if it doesn't simplify, we move it up. We get 3n plus 5. And we get n minus 8. Okay, number 23, same steps. So it's in standard form. We look for a greatest common factor. I'd like to say something divides out of this, but it doesn't. So we go ahead and we multiply the 9 to the back. That gives us r squared plus 56r plus 108 there. So we're looking for 108. And it looks like they need to add to 56 because everything is super positive here. So 108 would be like 12 times 9, which is what we just did. That adds to 21. If we divide 108 by 2, that's 2 and 54. Oh, victory. 2 and 54. Add to 56. Again, if we check our answer, r times r, nope, not giving us the 9r squared, so that means we need to continue our bottoms up, divide out the 9. So we've got the 9 that needs to move up here, 9r plus 2. And 56 divided by 9, if we're looking at that. Oh, I put in the wrong number. I'm so sorry. Not 56. 56 is that middle number. We wanted 54 in here. From our 54 over there. Divided by 9, we get r plus 6. Awesome. Okay, 24. Again, following those steps, it's in standard form. We look for a greatest common factor, always, always first. It looks like an n divides out of both of those, so we pull an n out front, and we get n squared divided by n is n. The n's go away in the next term, and we just get plus 7. Notice there's no n squareds left. There's nothing else to factor, so this guy's done. We're done with that. 25. Woohoo! Looks like these are all even numbers. They've got a greatest common factor of 2, but also of 3, which means also of 6. Let's do 6. So we're going to divide a 6 out of all of these, which leaves 3v squared minus 7v plus 4. Again, we're going to work through this. That 3 is in front, so we're going to bottoms up, right? Now remember, the 6 just keeps coming with us while we finish our bottoms up. So we've got 7v plus 12. So we need factors of 12 that give us negative 7v, so that would be like negative 3 and negative 4. So we've got v minus 3, v minus 4. And then we finish bottoms up by dividing out what we multiplied in. Now notice the 6 is out front. That is not what we're dividing back out. The 3 is what we multiplied in, so the 3 is what we divide back out. So in the end, we're going to have 6v minus 3 divided by 3 is 1. And it looks like the bottom needs to come up on that next piece, so 3v minus 4. Oh, it's moving around. All right, let's move to the back page. Again, factoring. So 26, it's in standard form. We look for a greatest common factor. Yikes, there's not one. So 2 ways you can do this. One, you can do bottoms up, although we talked about this is one of those special cases where we know that we can split this guy really nicely into 3v and 3v. We know that 16 splits nicely into 4 and 4, and if those have different signs, that results in there being no middle term. So this one we called the difference of squares because they have nice square roots that allow us to factor quickly. 27 is very similar. All we have to do is say, okay, well, there's a greatest common factor here of 5. 5 divides out of both of these. So we get 5, and we end up with 4n squared minus 1. Now, again, 4 splits up nicely into 2n and 2n. And 1 is 1 times 1, and then if we give them different signs, that allows us to factor that. Now, if you're better with the bottoms up, you can do that, but make sure you take that 5 out first. When you do that and you start your bottoms up, right, the 5 just comes with you, and you're going to have n squared minus 4. That's going to be n minus 2 and n plus 2, because they have to add to 0 in the middle there, and then you have to finish that bottoms up by multiplying out the 4. When you do that, you're going to end up with n minus the 1/2 and n plus 1/2, and then the 2 moves in front. So you'll get the same answer if I write it correctly. It's just a little quicker if we can recognize the pattern off the bat. All right, the last ones are solving by factoring. So again, we're just going to factor and then solve. So let's go through this, and we're just adding to that step of factoring. We make sure it's equal to 0. This guy's already equal to 0, so we go ahead and pull this apart. Looks like we can split that x up nicely. X and x, factors of 12 that equal 7 would be like 3 and 4. Everything's positive here. And then again, our one step here is then to solve. So what makes each piece 0? Well, this piece needs to be a negative 3 plus 3 to get 0, and this piece a negative 4. So this one you're asked to actually solve. Number 29, similar idea. There's no greatest common factor, so instead we need to use the bottoms up. So we get r squared plus r minus 42. Factors of negative 42 that have a difference of the 1r in the middle there would be like 6 and 7. Now it's a positive 1r, so we want the smaller number to be the negative. So r minus 6 and r plus 7. Finish your bottoms up by dividing back out that 2, and we get r minus 3. Move the 2 up, and we get 2r plus 7. Now I understand that I'm going through these quickly. Ideally, you should work through these first, and then go through if you get stuck on them to get kind of an explanation. So I want to make sure we're getting through them quickly, but that you've had time to think through them first. So make sure you've tried that. Looking at 30, this one's already factored for you, so it's tempting sometimes to want to start foiling it, but again, we're solving, so this would be like x is positive 8. And remember, if you can't remember what that would be because there's like a fractional value, just set it equal to 0. You would add the 5, 4x equals 5. You would divide the 4, so x must be equal to 5 over 4. Okay. 31, again, we got to follow these steps. First of all, moving everything to one side. So we've got b squared plus 5b minus 16 equals 8. We need it to equal 0, so we're going to subtract the 8 over and combine it with its like term. We get b squared plus 5b minus 24 equals 0. From there, we can go ahead and factor. It doesn't look like there's a greatest common factor, so we just split apart the b and the b. We need things that multiply to negative 24 that have a difference of 5. So like 6 and 4, that has a difference of 2. 8 and 3 have a difference of 5. And we want it to be a positive 5, so 8 minus 3. So we're going to positive 8 minus 3. So we're going to b equals negative 8 there from this first piece, and b is equal to positive 3 for that second piece. So if this is multiple choice, I'm going to choose A. Moving down, same idea. So we got to move everything to one side. I like my b squared or my squared term being positive, so I'm going to move everything towards that. So let's add the 12b. And I want to put it in standard form, so I'm going to put it right there in the middle because it doesn't combine with anything. So I have b squared plus 12b plus 38 equals 2. So we still need to move that 2. Let's combine it with the 38. b squared plus 12b plus 36 equals 0. It looks like there's no greatest common factor to be dealt with, so we just go ahead and factor and split that b up. Everything's positive here, so we need things that multiply to 36 and add to 12. That would be 6 and 6. Notice you've got b plus 6 and b plus 6, so when you solve this, you're going to have b is equal to negative 6. You can write it twice if you want to, or once is sufficient. Number 33, it looks like there is a greatest common factor. These all divide by 5. So if we pull the 5 out front, we're left with x squared plus 40x divided by 5 is 8x, and 75 divided by 5 is 15. So we've got 5, x, and x. We're going to split this up. Everything's very positive. That's great. So we need factors of 15 that add to 8. So 3 and 5 look great. And again, when we solve, that means that x could equal negative 3, x could equal negative 5. So if this is multiple choice, it looks like our answer is D. All right, last ones. Oh, I didn't even tell the last joke, so we better do the last one. This one I better draw a little picture for you. This is, how can you tell that fractions, and I'm going to draw these fractions for you, x over c, y over c, and z over c are on vacation in foreign countries? The answer is because they're all overseas. On vacations where we are not. All right, let's continue. For each of the following linear equations, you're going to write the equation in slope-intercept form to start with. So remember, slope-intercept form is y equals mx plus b, right? Because you've got your slope, you've got your y-intercept. And state the slope and the y-intercept. So we need to solve for y to put it in the y equals mx plus b. So we're going to move this whole term over. So we subtract the 4x. We get 5y is equal to negative 4x minus 15. Again, those don't combine because one has an x, one doesn't, but they can sit side by side. We then divide everything by 5 to get y by itself. So we get y is equal to negative 4/5 x. And negative 15 divided by 5 is negative 3. So for part A, our equation is y is equal to negative 4/5 x minus 3. We then move to finding the slope. So the slope from that equation is that negative 4/5. And C asks for the y-intercept, and the y-intercept in this case is negative 3, or if you want to write it as a point, it would be 0, negative 3. Last one, same idea, so we're solving for this y value, so we're going to subtract 7x to both sides, and we get negative 5y is equal to negative 7x minus 10. I just keep that in standard form because it's the norm. Then we divide by the negative 5, so we get y is equal to 7/5 x. Negative 10 divided by negative 5 is a positive 2. So in this case, when we write it out, part A, our equation is y is equal to 7/5 x plus 2. Our slope there is 7/5, and the y-intercept there on the end is 2. Very good. Again, you are allowed to use this review on your test, so if you've printed it off, if you've worked through it and understand it well, you should do fairly well on that test. Go ahead and fill in number 36, each of your answers to your jokes, for a bonus point on your test.